Welcome to the first lesson of this new unit. In this unit, we'll be talking about simple linear functions. Our first learning target is about being able to interpret the key features of a linear graph, including x and y intercepts and slope. Before we truly begin, we need to kind of define some of these words that we're going to be discussing in this unit. So a linear equation is an equation whose graph is a line. Okay? And I can graph this line on a coordinate plane. And how I am able to get a particular line is by looking at the two variables that are incorporated in the equation, which will be x and y. Okay? So each equation will have these two variables, and so we'll use both to help us get these graphs. But we need them to be in certain forms so that we can do that. So the first form we'll talk about is standard form. Standard form is a linear equation in the form of ax plus by equals c. So the a, b, and c are all representing numbers. Okay? X and y are our variables. So when you get an example of this, it may look like 2x plus 3y equals 6. So notice that all those letters of A, B, and C are gone, and now they're replaced with numbers. And so there will be a point where we start graphing these using equations that look like this. Okay? The next thing we would like to talk about is something called slope. Slope is referred to as the steepness of a line. Okay? It's a number that is a ratio that describes the tilt of a line. Okay? And we mainly describe slope as the ratio of a rise over run. There are different kinds of slopes, whether they're positive or negative. But there are two in particular that are unique. One is undefined slope. This will happen, is going to give you a vertical line. Because that means the run is 0. So that's the bottom number. And any number divided by 0 is undefined. Okay? Slope, when it's equal to 0, gives you a horizontal line. Because the rise is 0 And when you divide, and 0 divided by any number is 0. Okay, so maybe going back to this graph, it'd be nice to define what do I mean by rise and run. So here, if I'm going to the right or to the left, I'm talking about the run. So it's the change in the x value as you move left or right. So how far, like if you think about it as a horizontal line, so like it's the ground, and so you can walk on the ground. So how far do you run from one point to the next? Okay? And then the other piece would be the rise. So how far do you go up or down determines the value of the rise. Okay? So if the run is 0, that means there's only rise, so it's straight up and down. You're not moving left or right, so then therefore it's an undefined or vertical line. When you have a slope of 0 or horizontal line, that means you're running because it's all ground, but you're not going up or down. So there is no steepness or tilt to that line, so that's why the slope is 0. A couple other vocab words that we would like to define are x and y intercepts. So an x-intercept is the point at which your linear equation and x-axis intersect. Okay, the y-intercept is very similar, but this is a point at which your linear equation and the y-axis intersect. Okay, so now from there we want to be able to determine whether we can see if something's linear or not linear. So there are a couple examples here at the bottom that we'd like to use to help us determine that. Now, what do you think we need to be looking for? Okay, in your problems or your equations, you want no exponents. You want no square roots. You want no absolute value signs. And you do not want any multiplication or division of two variables with one another. Okay, so that way it kind of makes your equations create a line. With exponents, you can get curves. Same thing with square roots. With an absolute value sign, you get like a V shape. And with multiplication divisions of your variables, you get like kind of curved lines. But they're a little different because there's a break that happens that's unlike 1 and 2. 2, it's almost like they cut off part of the graph to give you part of a curve, but they're very unique equations. Some of them we'll talk about later down the road, but for right now we're just talking about straight line equations. So if they have any of these, that means it's a no. Okay, If they don't have any of these things, then you can say that it is a linear equation because it passes all these tests. So looking at number 1, you have y equals 4 minus 3x. I don't see any exponents or square roots. Remember, square root is something that looks like that. Absolute value bars, doesn't have those. And 3 and x are multiplied to each other, which is fine, but x and y are not multiplied to each other, so that's okay. So I would say yes, this is a linear equation, okay? X squared plus 2 equals 9 is number 2. I see an exponent up here, so that means it's a no because it has that thing. Okay. Number 3, looking at that one, I see that there's an absolute value bar on either side of x minus 2, so that means this one's a no. 4, don't see any exponents, no square roots, no absolute value signs, and no multiplication division between x and y. You have x times 8, which is fine, and y times 7, which is fine, but not times each other. Okay, so this one would be a yes. Okay, this is where we'll stop for this video for part 1. Move on to the next video for part 2.